Saxon Algebra 1, Lesson 77. Greetings, gentlemen. Thank you for joining me for this lovely conversation that we're going to have. It's a two-parter today about, first of all, consecutive even and odd integer problems. Now, it wasn't too long ago. Let me just see if I can find it real fast. Oh, when was it? There it is. It was just 76. We talked about these consecutive integer word problems, right? And what we were trying to find is three numbers in a row that are the solution to what we're looking for, right? And so if we envision that on a number line, we're looking like we don't even have to put, well, I'll do it. I was going to be lazy and not even put the numbers on. Okay, so what we were looking for when we were looking for consecutive integers, we were saying like, okay, but about like 1, 2, 3, right? And we would call this one n, and we'd call this one n plus 1, and we'd call this one n plus 2, right? Remember how we set the variables up in that oh so clever way? Okay, that was consecutive integers. But what if we want to envision a problem where we're finding consecutive even integers? I know you're copying madly. I'll breathe for a second to give you a chance to catch up. Okay, what about consecutive even integers? Okay, that might look something like this. What about like -2, 0, and 2? Those would be three consecutive even integers. They're even numbers. They're not decimals or fractions. They're even, and they're in a row. We didn't skip over any, right? Boom, ba boom, ba boom. Now, before we just added 1, but we can see here, look, we're going to have to start, if we call this one n, then this one will have to be n plus 2, and this one will have to be n plus 3. Oh, I'm sorry, no, 4. That was ridiculous, right? We have to add 2 numbers because we're skipping every other, right? Sorry, that was ridiculous. Does that make sense to you? Yes, teacher. Oh my God, I could hear you. That's so cool. Okay, what if we want, and this is where everybody's mind gets just a little bit blown, what if we want consecutive odd integers? All right, let me just crank through this again. I know you are too, so I'll try not to go too fast. There, I'll make it go up to 5. Consecutive odd integers. Now it seems like, okay, if this one we added 2 and 4, then here maybe we should add like 1 and 3. But look what happens. Let's pick 3 odd integers in a row. I'll pick -1, +1, and 3. All right, those are consecutive and they're odd. Let's call this one 1, this one n. Now, how many do we have to jump up here? It's still n plus 2 to get to the next odd integer. And then it's still n plus 4. Let me just divide these so that the name goes with the right number line. Do you see what I'm saying? When we wanted the even integers, we added 2 and then 4 because we have to skip over every other number, right? Well, it works just the same when we want the odd integers. We have to skip over every other one. So whether we want the evens or the odds, we use these same variable designs to get the every other factor, right? It doesn't matter that we're adding even numbers here. That just gives us the every other. It'll work for evens as well as odds. Okay, so that's what we're going to do in these problems, is we're not going to do consecutive integers. We're going to do either consecutive evens or consecutive odds. And these problems just have a way of working out because John set them up properly. So you don't really have to worry too much about the even and oddness other than setting this up right. Let's jump in and you'll see what I mean. Find 3 consecutive even integers such that blah, 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 blah. Let's set up the things first. The first is going to be n. That's the easiest one. The second is going to be n plus 2, right? Because we want to skip over one. And then the third will be not n plus 3. That was me being crazy. N plus 4. Make sense? Okay, so now we've got this set up. Now let's get into our drama. Such that the sum of the first and the second, okay, the sum of the first and the second equals the sum of the third and negative 10. So the sum of the third, n plus 4 minus 10. Now, I didn't need those parentheses, did I? I thought maybe they were going to tell us to multiply that by something because a lot of times he does. So I didn't actually need those, and I didn't put any here. It doesn't make any difference. Parentheses can be forgiving if there's nothing written on the outside of them. All right? Okay, let's add like terms. Ready? Those and those. So 2n plus 2, not n squared because we're adding. Oh, that's such an easy mistake to make. Here we are adding, so it's 2n, not n squared, equals n minus 6. All right, let's subtract 2 from both sides, and then let's subtract that n. Let's swim him over this way. Goodbye, goodbye. N equals negative 8. Oh, okay. So our first one is negative 8. Then our second one is going to be negative 6. And our third one is going to be negative 4. Be careful when you add. Remember that on the number line, we're always moving from left to right as we create new variables because we're always adding, right? So we always are moving this way. Sometimes I want to make this negative 8, negative 10, negative 12. That my brain sometimes wants to do that, but that's wrong. We can write the answer like that. Yeah, that's a good way to write the answer. All right, so we didn't have to do anything fancy to make sure that these turned out to be even numbers instead of odd, because we would have used the same variables if it told us that these were odd integers. So you don't have to do anything special. The numbers work out the way they're supposed to. All right, let's do more, right? We're having so much fun. We need to do more. I'm sure that's exactly the thought going through your mind right now. Find 3 consecutive odd integers such that, whenever I see the word such that, I pause because I know it means blah, 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 blah. Here comes a bunch of confusing information. So first I want to do this. And you guys, even though I've done a lot of these problems, I still like to write it out every single time. Okay, the first one's n. Now these are consecutive odds. So I want every other number. So even though it seems weird that I'm using even numbers when I'm trying to find odd consecutive integers, that's the way it works. All right, so I'm all set up. Now let's do the dramatic thing. The sum of the first and the third, okay, so n plus 4, is greater than, I'm not going to tell you the number how many, the second decreased by 18. That means subtract. Okay, this side is bigger, this side is smaller. I always like to do this side because there's room to write right there. So I'm going to have to add to this side, aren't I? Because he's the jumbo. That's the shrimp. Jumbo shrimp is my favorite oxymoron, by the way. And it's 7 greater. So if I add 7, that will bring these into balance, and I can do that. Right? Now the jumbo stays the same, but I bumped up the shrimp, so we're good. Okay, now we're ready to solve. Add like terms. That one has a lot. 2n, remember that's adding, so it's not n squared, plus 4 equals n. Okay, I've got 2 positives. That makes positive 9. Minus 18, that looks like minus 9 to me. Okay. I want to swim my n over here, which means I'll have to move my plane number over there. N, goodbye, goodbye, equals minus 13. Well, that's an odd number. We didn't do anything special to make that happen. It just fell out of the sky and we're happy. So here we go. N equals negative 13. We add 2, so that means negative 11. And then we add 4 to this, and that makes it negative 9. Yay. John's really into this idea of then taking these values and plugging them back in and checking. You can check any algebra problem by plugging your solution back in. There's nothing different about these. I don't know why he's so fascinated with it. I don't need you to do that. If John says in the instructions, check your answer, then you should check your answer. If he doesn't say check your answer, then why? That's my philosophy. 77.3. Find 4 consecutive odd integers. John, 4? Are you kidding me right now? I like to write this down because the problem always refers to, you know, the first and the third are added together and they stand on a monkey and look at the fourth or whatever. So I like to have first, second, third, fourth because I know that's what he's going to say in the problem and it helps me match. Okay, n plus 2. Again, we want the odd ones, so we're taking every other. And we haven't had a fourth one before, but obviously we just keep adding 2, right? All right, here we go. Such that, that's where I always pick up. The sum, oh no, that's the wrong problem. Such that the first and the fourth, now he doesn't say, oh no, he does say the sum. The sum of the first and the fourth, okay, the first is n. The fourth is n plus 6. The sum of the first and the fourth is greater than, I'm not going to tell you how many, the opposite of the third. Okay, now, opposite means put a minus sign in front of it. I just did that lesson with the Blue Book kids. But if we just write it like this, the opposite of the third, if we don't put parentheses on here, then we're only changing the sign of the n, and that's not good enough. Okay, it says the opposite of the third. So we take the third number, put it in parentheses, and then put a minus sign right out in front. All right, these parentheses we have to have because we want this minus sign to apply to both parts. Okay, he's the jumbo, he's the shrimp. 25 is our balancing number. So I want to add, I always want to change this side. So I'm going to add to my shrimp. The number's 25, and now we're equal. All right, I feel so much better. Add like terms, distribute, and then we'll combine these as we go. 2n, we're adding, not multiplying. I said that every time, didn't I? Minus n, and then this will become a minus 4. So when I combine it with the plus 25, it'll be plus 21. Do you like it? I like it. All right. Time to swim some fish. I'm always going to favor him. Let's add n. And then we'll have to swim the plane number that way. Goodbye, goodbye. You can choose to do this however you want. You'll get the right answer as long as you work accurately. There's no one right way to swim numbers, as I'm sure you know, but I'm just reminding you. Do what makes you happy. All right, 3n equals 15. N equals 5. That's an odd number. Now we start adding. 7, 9, 11. Our formulas gave us exactly what we wanted. Those are the right answers. This is how I like to see them presented. Remember, you guys, I want you to set these problems up exactly like I do. Make your list of variables over here. You can squish it a little tighter if you want. I put lots of space because you need to be able to see from afar. I mean, I think it looks neat, but if you squish a little bit more, but I want your lists here. I want you to say first, second, third. I want you to show that. Then do your work over here. Show the steps just like I do. Show me what your N is, and then bring it over and document. You guys are both very neat. Well, and anyone else who's listening, you know, be a neat, accurate worker. Lay your problems out with a very rational organization, and you will go far. I know that's what you want. You want to go far in algebra. Far away. Okay, part B. We're going to do some frickin' formula review. Fraction and decimal word problems. All right. If you were not with me last year, there's a thing called the frickin' formula, and I'm not afraid to use it. These are the problems where we have a group of something. My favorite example is a bag of Skittles poured out on the table, and your mom says you can take 1/5 of those. And you need to figure out how many is your share. Okay, so this stands for the fraction or the decimal. The of number represents the total group, and the is number is a special group that belongs to you. We're going to do some stories now, and we're going to draw some pictures. These are the formulas we'll be using. There's also a percent version of this that we will spend a lot of time using. So make sure you have it in the notes. What I'd like you to do right now is flip to your cover and make sure you have these written down. It's okay if you write them more than once. Pause me and I'll wait till you get back. Bye. Oh, look, you're back. $77.4. How many of these do we have? 1, 2, 3. Woo! Long lesson. Lopez used a 5-iron, but the ball covered only 4/5 of the required distance. If she hit the ball 112 yards, what was the required distance? I see what we got going here. We got a little golf problem, right? We've got, in PE when I was in high school, we had to design a golf course, and that was a really fun project. I enjoyed it very much. Okay, but we've got this golfer, Lopez. There is a pro from decades ago whose name was Lopez, right? What was his first name? I can't think of it. Woody. Maybe it was Woody. Oh, no, that wasn't you guys. I was talking to the Blue Book kids, Jojo and Joel and Alexis, about Toy Story, because I referenced To Infinity and Beyond, which is Buzz Lightyear, not Bud, Buzz Lightyear, voiced by Tim Allen in the movie Toy Story. And then I was referencing the little cowboy, voiced by Tom Hanks, and I couldn't think of the cowboy's name. So today, I was talking to my daughters, and they were like, Mom, Woody, come on. And I'm like, oh, right. So I was referencing Woody, and that was to them, but then I just told you, and you didn't know what I was talking about, so I'm telling you, this is harder than it looks, you guys. Trying to keep all of the right references with the right class, it's not easy. Okay, so she hits the ball. It's supposed to go some full distance, right? And we set that equal to 1, but it didn't go the full way. So it went 4/5 of the way, but it fell short by 1/5 of the distance, right? Does that make sense? Let me read it again. Lopez used a 5-iron. That's just distracting information. But the ball covered only 4/5 of the required distance. If she hit the ball 112 yards, okay, that's how far she actually hit it. What was the required distance? Right there. Make sense? Let me read it again. She used a 5-iron, but the ball went only 4/5 of the required distance. If she hit the ball 112 yards, what was the required distance? You guys, these problems are so easy to watch me do and listen to the words and go, yeah, of course, that's so obvious. Why does she keep saying it? It's so obvious. Then you're all alone in your room trying to do your homework, and you're like crying and ripping up pieces of paper because it's not that easy to figure it out on your own, right? So don't be sad. Just keep trying. Okay, and John does not use this formula. This formula is the magic, you guys. Remember, this is the of word. These are the is numbers. And the fraction, decimal, or percent. I don't mean multiplying there. Those are what we will write right here on side of it, on the side of it. Let me put puffy clouds. Oh, I just turned them into flowers. How cute is that? Little pansies in our garden. What am I talking about? I don't know. So in any case, the diagram and the variables as we lay them out fit together perfectly. This is the of number. These are the is numbers. These are the fractions, decimals, or percents. All right. So what we want to do is set up a formula now. 4/5, I'll write it here. 4/5 is our fraction times the of number, which is x, equals our special group number, which is 1/12. Notice that I'm careful to choose the fraction and the number that go together. I don't want 1/5 and 1/12. They don't go together. They're on opposite parts of the diagram. Okay, so I'm going to copy this to the next page. Four fifths x equals 1/12. All right, there's our variable. He's being attacked by this 4/5 monster. We'll make it go away with a reciprocal. Looks good, right? Now we need to reduce. John always makes these come out easy. 4 into 1/12. I'll tell you how I'm going to break that down. First, I'm going to do 4 into 100. That's 25 times. 4 times, no. 25 times 4 equals 100. And then we have to do 12 more. 3 times 4 equals 12. So if I take 112 and divide it by 4, then I know the answer is 28. Wait. Yes, sorry. 28. And now, there's nothing left in my denominator, so I can't do any more canceling, and I just need to do 28 times 5, and here's how I'm going to do that. 5 times 20 equals 100. 5 times 8 equals 40. So x equals 140. This is just my mental math. Now I go back over here, flippity flop, and I see that the required distance that we just calculated was 140 yards. That's how far Ms. Lopez needed to hit the ball. She only got 4/5 of the way there. I mean, we could debate whether the 5-iron was the right one. She really needed a little bit more, a little less angle on that pitch. I think she should have gone maybe with a 6 or a 7. But we can also figure out how far she fell short because it's the difference, isn't it? It would be 140 minus 112, which is what, 28, right? And I like to fill in my chart completely when I'm done. Yay. Okay. We are doing, no, we're not doing percents. Ready? Let's do the next one. Example, 77 point, what are we up to, 5? Yes. Micah B guessed that the total was 30.24. So maybe that's how many jelly beans are in a jar. But this was 7.2 times the total. Okay, so this is the actual total in the jar. And our friend Maccabee, his guess was too big. He guessed 30.24. And this was 7.2 times too big. Whoops. So this tells me that if I take the amount here, the amount that we're actually in the jar, we just do this. D times of equals is, right? This is my of number, always. This is my is number. And this is my decimal. Whoop. So I'm going to use this. 7.2 times x equals 30.24. Decimal times of equals is. I hope you can see that. All the pointing just makes me confused. All right, so now all we have to do, divide by 7.2. So I'm going to do that over here. This is the straight algebra part, right? Okay, what are the rules of decimals in division? I mean, they're too complicated. I'll tell you that right now. We have to jump that one all the way to the edge, jump that the same number of times, and then put it straight up. All right, that's reasonable. We can do that. How many times does 72 go into 302? That's really hard. I don't know, but I'll tell you what, I can guess. 7 into 30 goes 4 times. So I'm just going to guess 4 right there and see what happens. 4 times 2 is 8. 4 times 7 is 28. Okay, that lined up pretty good. That looks like the way I want it. Now we subtract. Good Lord, I have to borrow all of that. Yikes. 4, 1, and I'll bring down the last 4. 72, oh look, that's going to work out really well because 7 into 14 goes twice, and then 2 times 2 is 4. I think it's going to be perfect. 2 times 2 is 4. 2 times 7 is 14. Yep, it worked out. So our answer, x equals 4.2. Now let's figure out what the heck that means, right? We got all involved in the math and we forgot about our picture. That's why I like to start by drawing the picture first, is it'll help you get going. And then when you're done, you just go in and fill in the last few details. Okay, so that means the number of jelly beans in the jar was actually 4.2. That wouldn't be a very, you know those challenges where it's like a jar jammed full of jelly beans and you have to guess how many there are? It wouldn't be a very hard challenge if there were 4.2 jelly beans in the original jar. You could count them, but that was just the story I made up. Okay, so that tells us that's how many jelly beans there were to start with. That's the right answer. And this is our completed diagram. Even though most students sort of swoon and get a headache when they see it's this peanut/toddler baby Jesus style problem where the group is getting bigger, it's actually easier because there aren't as many numbers, right? The other kind is where we divide into 2, the ice cream sundae style, and that has more detail to fill in. And that's what we're going to do next. Oh my gosh, speak of the devil. Except they're not devil, they're delight. Last one. 3/4 of the tickets had been sold, and there were 420 tickets left. How many tickets were printed? All right. These are the tickets printed. Of those, some were sold, whoops, and some were not sold. That's the basic situation we have here. Let me go back and get the numbers. 3/4 of the tickets had been sold. Okay. Well, my picture doesn't really reflect 3/4, but that's okay. So we know right away that means 1/4 were not sold. Remember, this always represents one whole if we're working with fractions or decimals. 420 tickets were left. That would be the not solds. Oh, how many tickets were printed. Okay, so in this case, we got information about the number of tickets that were sold, but then we were given the total number that were not sold, and we need this percentage, don't we? Because we can't match this fraction with this number. They're not friends. They represent different things. So we needed, I just did this for fun to fill in the picture, but this is the fraction that we're going to use to build our equation. F times of equals is. Remember, this side of the diagram is always the of number. This side, is the is, and then the fraction or the decimal or the percent we put outside. This fraction, decimal percent, is always 1 or 100%. All right? This has got the more interesting fractions or decimals. Okay? So we're ready to set this puppy up. The fraction that we need is 1/4. The of number, we don't know, equals the is number is 420. And we always double check to make sure, did I take the fraction that is on the same part of the picture as my diagram or my number? Yes, they match. We don't want to mix. Okay, yay. All we have to do now is hit it with a reciprocal stick, right? If that's a thing. This cancels. There's the x by itself. We don't even need the 1, right? 420 times 4 is 1,600 plus 80, right? I did 4 times 400, and then I did 4 times 20. And so my total is 1,680 equals x. I can box that, but I'm also going to go up here. 1,680 tickets were printed. And now, because I just like to be thorough, I'm going to figure out how many tickets were sold. I can do that by subtracting this from that. And that will be what? 1,260. These should add 861. Yeah, okay. So, moral of the story, even if John doesn't tell you to, complete the diagram. All the fractions, all the numbers filled in. Okay? Yay, we got it right. That was a long flipping lesson. Thank you for not fainting. I mean, I assume you didn't faint. Maybe you fainted and had to watch it twice and go back to where you keeled over. I don't know. It's possible. But in any case, we're done. Yay. Thank you for hanging in there. Bye.